Hello, this is Xinru. In this video, we are going to take a look at Leetcode question 437, Path Sum 3. In this question, unlike the previous question, you're given a binary tree in which each node contains an integer value, and we need to find the number of the paths that sum to a given value. And this path is different with the previous question, that the path should start from the root and end with leaf. But in this question, the path doesn't have to start from the root or end at the leaf, but it must go downwards. So it can only traveling from parent nodes to child nodes. And we need to return the number of paths. And to solve this question, first, we have to analyze the definition of the path. So as you can see, there are two uncertainty of this path. So first is the start of the path doesn't have to be the root. Therefore, we have to, if we want to do it in a recursive way, we have to start from every node. We have to traverse through the tree and call the recursive function in every node. And the second part is it doesn't need to end with a leaf. Therefore, so compared to the previous question, we don't need to check if the node is a leaf. So we get a feeling that because the start of the path is uncertain, therefore we need to use two recursive function, and the second recursive function should call the first recursive function with every node it travels through. So let's get into coding. First, let's define our recursive function. Let's say it's count from node. So this recursive function, we're given two parameters. One is node, another is sum. And we can say if node doesn't exist, then we just simply return 0 here. And if as you can see, because the end of the path doesn't have to be a leaf, therefore we can just compare the sum with a no.value, and if they're equal, then we can add the count. So first we need to define a variable count inside our recursive function. So we define it as 0. And every time when the sum is equals to no.value, that means the path has been found. So we have found one path, therefore we can increment count. And another thing is in this function, we have to go through the left node and the right node. So we have to do a depth-first search in this recursive function because we need to find out how many paths we can find. Therefore, we can define the result that returns from this recursive function when we traverse through the left node. So we say count from nodes and node.left and sum minus node.value. And then we also define the right node in the same manner. So node.right sum minus node.value. So after we defined both, so what we know is that we need to return the current count, because when we call those left node and right node, it will start looking for the path starting from the current node when we call this count from node function. So what we should do is return count plus L plus R. So that's what we are going to do. And outside of this recursive function, as I have already mentioned, that the start of the path doesn't have to be a root. Therefore, we have to call this recursive function. We have to call the first recursive function of every node in this tree. Therefore, we can make the second function another recursive function. So basically what we can do is, first, if the root doesn't exist, then we just return 0. And if the root exists, what will we do is we will return first count from node. Okay, just to make this concept clear, so what I will do is, first I will start from the root. So I will say count starting from node. I will put it, and when you call this count from node, you will get node root start from root, I should say count start from root, and I call the root and sum. And then what we can do, then we need to we need to make the path sum also another recursive function and calling different node, but the sum value should be the same, because we're trying to find out different paths. We're trying to find out the paths that not start from the root, but start from other node. Any other node, as long as it's not the leaf node. Therefore, what we can do is we can return count starting from, it should not be root, because when we call this function, we will start from the current node. So what I will say is count starting from current node plus we will call the function itself path sum of root dot left and sum plus path sum of root dot right of sum. So let's submit the solution. As you can see, so in this question, there are two differences from the first question, from the previous question. So the first thing is the end of root is not necessary to be a leaf. So we did some modification that we don't check if the node is a leaf node, because end of the path is not a leaf in this question. And the second difference is that the start of the path doesn't have to be the root. Therefore, we make this path sum another recursive function of calling the first recursive function constantly. So that's the second difference. So because of the start of the path is not a root. So that's the major difference between this question and the previous path sum question.